the symbol for magnetic field is B, but the unit is Tesla's. And no, not the car company, the actual human being, Nikola Tesla. I appreciate. I had someone in another class that's like, so Elon Musk named him? I'm like, yes. In the last 10 years, we finally gave magnetic field a unit. Before that, we're like, yeah. So yeah, it's Tesla's the Nikola Tesla. Okay. What's the equation for finding the strength of the magnetic field? All right. I'm going to give you the equation, and then I'll explain what all the symbols mean. Here's the equation. B equals mu naught I over 2 pi r. So let me tell you what all these things stand for, and then I'll draw you an example of what it looks like. Okay, so first of all, B stands for magnetic field. I is current. R is radius. More on that in a second. And mu naught is called the permeability of free space, which is, it is my favorite scientific constant. It's just terrific. Actually, my favorite is the permittivity of free space, but they're interchangeable. Permeability of free space. Now, I know that sounds super complicated, so let me make it easier for you. It is how easy do magnetic fields travel through empty space. That's what this is. This tells you how easily do magnetic fields go through empty space. And the value for it is 4 pi times 10 to the negative 7th. That's the value for mu naught.
Where did they get that?
So they did it by measuring the permeability of magnetic fields through different materials. And based off of that, they could figure out the constant that relates to it. 4 pi times 10 to the negative 7th. There is a unit to this, obviously. It's Tesla meters per amp. I'm not worried about the unit. That usually confuses people. So this is what the equation looks like. So you might be saying to yourself, well, Mr. B, this doesn't make any sense. Why do we got radius? Is that the radius of the wire? No. Here's my wire. Here's why radius is involved. If that's the wire, the magnetic field is a circle around it. Remember, we said that magnetic fields are created by moving electric charges. Hey, guess what? Current is moving electric charges, so it makes a magnetic field. But it doesn't make a magnetic field out. It makes a magnetic field around. So the radius is how far from the wire are you looking? How far from the wire are you looking? So let me give you a simple example. Let's say that I want to find what is the strength of B 2 centimeters from a 2 amp wire. Well, I would say B equals mu naught, which is this number always, 4 pi times 10 to the negative 7th. And then I would multiply by the current, which is 2. and I would divide it by 2 times pi times r. And the r is the meters away. So this would be 0.02 meters. And that's it. You multiply the numbers together to get an answer. So when I solve this, 4 times pi.
What was the unit for mu?
Huh?
Mu was what?
The unit, if you want to know it, is Tesla meters per amp. So the unit comes from Tesla's meters per amp, so that they cancel out with each other.
To make sure I have this right, mu naught is defined as the permeability of free space, which is how easily magnetic fields travel in empty space.
Yes. Yep. All right, so I would plug these numbers in. So 4 times pi, here, let me just show you how I'd plug it in. So 4 times pi, 12.56, 6, so we'll do 12.57. I need to do the times 10 to the negative 7, so negative 7. Multiply that by 2. And now divide it by 2 pi r. So 2 times pi times 0.02. So that would be my magnetic field. My magnetic field would be 2.0 times 10 to the negative 1, 2, 3, 4, 5. Now, I will frequently give you numbers that will be a little bit simpler sometimes. At least I try to if possible. So like, for example, the example you're going to do here will be number 10. I gave kind of larger currents and distances to try to make the numbers match up a little bit better. What was your number for the answer I got was 2.0 times 10 to the negative 5th. All right, last thing for today before I give you one problem to work on. How do I find the, 3. How do I find the direction? All right. There's 2 things. They're both called the right-hand rule. Get excited. This one is super easy. This one actually is super easy. Okay, here's how you do it. Get your right hand out. No, you can't do the left-hand rule. Has to be the right-hand rule. Okay, no one cares about left-handed people. Here's what you do. Ready? Stick your thumb out and curl your fingers. That's it. That's literally it. So now, you take your thumb and you point it in the direction of the current. Okay, the current is to the right. That's why I drew it. Okay, so I'm standing here. Bam! Current to the right. Okay? Your fingers curl in the direction. So if the current is to the right, the field is, now I look at it, it's like, oh, it's clockwise. What happens if the current goes in the other direction? Oh, look, now it's counterclockwise. That's literally it. That's literally it. So, to answer my final thing, I need to know the direction. Well, I drew my current to the right. So I stand there and I say, thumb goes to the right. Curl my fingers in a fist of anger. What direction do my fingers go? They go clockwise. So my answer would be 2.0 times 10 to the negative 5th Teslas clockwise. There you go. That's it. All right, you got 5 minutes. Ooh, you got more than that. You got 7 minutes to do number 12. That's it. Just 12. A straight wire carries a current 0.5 amps out of the case. So stab yourself in the face with your finger. Well, with your thumb. Determine the magnitude and the direction of the field 0.03 meters away. And if you're like, Mr. B, I don't like scientific notation for my answers, that's fine. Just write it as 0.000. If there's a bunch of decimals, just write it out as small. That's fine. So, number 12, that's the only one you need to do. Don't worry about 10 and 11. We'll do them next time. Don't worry about finishing the notes on the front page. We'll do that next time. So go ahead and solve that and see what you can get. Yeah, I'll also, I recorded this, so I'll post the video online. But thank you for mentioning that so I don't forget to stop it. Yes, if you need the example problem, I'm going to post this video